Solution: volume of gas at STP is obtained by using the general gas equation P1 V1 T1 equal to P2 V2 over T2. Making V2 the subject of the formula, we have that P1 V1 T2 all over T2 P2, where P1 is 753 mm of pressure, V1 is 267 cubic centimeter, T1 is 18 plus 273, which will give us 291 Kelvin. P2 is now equal to 760 mm pressure. T2 is now equal to 0 plus 273, which will give us 273 Kelvin. Substituting the values into the equation, we have that V2 will now be equal to P1, which is 753 times V1, which is 267 times T2, which is 273, divided by T2, which is 291, times P2, which is 760, which will now give us 248 cm cube after the computation. 248 cm cube of the gas weighs 0.162 gram at STP. Therefore, 1000 cm cube of the gas weighs 1000 divided by 248 times 0.162 gram at STP, which will now give us 0.653 gram per dm cube. Molar mass equal to molar volume times density. Therefore, molar mass of gas equals to 22.4 dm cube times 0.653 gram per dm cube. Therefore, the molar mass of the gas is equal to 14.63. Molar volume of gases. Molar volume. Molar volume is the volume of gas occupied by 1 mole of any gas at STP. All gases occupy the same molar volume of 22.4 dm cube at STP. Example 11. Calculate the volume of the following at STP. 1. 3.2 gram of oxygen. 2. 51 gram of hydrogen sulfide. 3. 55 gram of carbon 4 oxide. Solution: for number 1, 1 mole of oxygen is now equal to 16 times 2, which will give us 32 gram. Therefore, 32 gram of oxygen occupy 22.2 dm cube or at STP. 3.2 gram of oxygen occupy 2.24 dm cube. Solution for question 2. 1 mole of hydrogen sulfide equal to 2 plus 32, which will give us 34 gram. Therefore, 34 gram of hydrogen sulfide occupy 22.4 dm cube at SCP. 51 gram of hydrogen sulfide occupied 22.4 divided by 34 times 51 divided by 1, which will give us 33.6 dm cube. For the 3, we have that 1 mole of carbon 4 oxide is equal to 12 plus 2 times 16 of oxygen, which will give us 44 gram. 44 gram of carbon 4 oxide occupy 22.4 dm cube at STP. Therefore, 55 gram of carbon 4 oxide occupy 22.4 divided by 44 times 55 over 1, which will give us 28 dm cube. Example 12. Calculate the mass at 22.4 dm cube at STP of ammonia, chlorine, and nitrogen 4 oxide. Solution: 1 mole of nitrogen weighs 14 for nitrogen and 3 atoms for hydrogen, which will give us 17 gram. But 22.4 dm cube of ammonia is occupied by 1 mole. Therefore, mass of 22.4 dm cube of ammonia at STP is 17 gram. For the solution 2, 1 mole of chlorine Cl2 weighs 35.5 times 2, which is equals to 71 gram. But 22.4 dm cube of chlorine is occupied by 1 mole. Therefore, mass of 22.4 dm cube of chlorine at STP is equals to 71 gram. Solution for the third question. 1 mole of nitrogen 4 oxide weight 2 times 14 for nitrogen, 14 atoms of nitrogen plus 16 atom of oxygen will give us 44 gram. But 22.4 dm cube of sodium for nitrogen 4 oxide is occupied by 1 mole. Therefore, mass of 22.4 dm cube of nitrogen 4 oxide at STP is 44 gram. Chapter 8. Graham's law of diffusion. Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of gas R is inversely proportional to the square root of its density D. That is, R is equals to 1 over square root of D, or R is equals to constant times 1 over square root of D, or R times square root of D, which is equals to a constant. For two gases whose rate of diffusion are R1 and R2 respectively, and whose densities are D1 and D2 respectively, then R1 times square root of D1 is equals to R2 times square root of D2, or R1 over R2 equals to square root of D2 over square root of D1, or R1 over R2 equals to square root of D2 over D1. Rate is the reciprocal of time t, that is, R is equals to 1 over t, but substituting R1 equals to 1 over T1 and R2 equals to 1 over T2, we get R1 over R2 equal to T2 over T1 is equals to square root of D2 over D1. Density is equals to half of relative molar mass of gases. Therefore, density is proportional to the relative molar mass m of a gas. Thus, in place of density, we can substitute relative molar mass, that is, R1 over R2 equals to square root of m2 over square root of m1, where R1 and R2 are the rate of diffusion of gas 1 and 2, and m1 and m2 are their respective molar mass. Generally, R1 over R2 equal to T2 over T1 equal to square root of D2 over D1 equal to square root of M2 over M1. Note, the important thing is to know Graham's law and know the relationship between rate R and time T, the relationship between density D and the relative molar mass M. Which of the formula to use depends on the nature of the question. Example 1. 200 cm cube of